These kind of problems are really useful, right? If you can identify someone else's mistake, that really means you kind of know what you're doing, okay? So in these order of operations problems, identifying the mistake, typically I would ask you to circle where the mistake is, okay? So this right here, when they did 6 to the second power, that means that they did this multiplication first before the exponent, which violates the order of operations. So that's the mistake, and explaining what it is, okay? Don't, like, just saying multiply. That's not enough. Okay, what did they do? That they should have done the exponent before the multiplication, or their mistake was that they multiplied before evaluating the exponent. Okay, and then correcting it, which is a little confusing in the way this problem is set up, right? Because now this person continues on with their mistake. You have to look at the other stuff there. Yeah, this is wrong, but we already covered that mistake. We know why this 36 is there, okay? But the rest of the problem, he's making more mistakes, or she, okay? And so identifying multiple mistakes in these problems can be difficult. Typically, what you would do for this is rewrite the entire thing yourself without having all this extra gobbledygook in here, and then you can say, you know, here's the way it really should be. All right, so there's 2 mistakes in this one. Here he did the multiplication before dividing instead of going left to right at the same time. And over here, this is very common for not good math people to do this addition first, 2 plus 8, and then do the multiplication. So that's the mistake there, that they added first. The rest of that's all fine. Most of you got that one right anyway. Plus I explained it in the video, right? Okay, then we go to part 2. And there were some really good notes in here, some Mr. Yucks, right, about stuff I don't like in the book, how to define a variable, make sure there's units in them. All right, so here's what we're going to do now. We're going to do a couple problems off of this guided practice on page 8. If you had your book and you wanted to look at that, you could, okay, or you could just read it right off the board here if it's big enough. Let's see, we'll do problem number 8, pick a good one, number 8, and we will do number 4, and number 9, GH over J. Okay. 1 pint is the same. Suppose the number is represented by P, write it, and we should do number 11 too. Okay. Now I could give you these to do as practice, but instead I'm going to show you how I do these problems, right? As an extra example before you start the homework. Okay. So I'm going to cut the numbers down probably. All right, so number 8. 3 parentheses 20 minus 7 plus 1. Okay, so I got some brackets here, some parentheses. We start with parentheses first and grouping symbols and go from the inside out. This I haven't done anything with, so I write it in there. 20 minus 7 is 13. Everything else I keep the same. I still have grouping symbols. Now these parentheses now don't mean anything. Right? There's no operations inside these parentheses to do. They're just there holding this answer together and helping us with multiplication a lot of times, right? Because putting numbers in parentheses lets you write multiplication easily. Okay, so don't worry that there's parentheses here. They're not really there. They don't need to be there. There's no operation to do inside of them. So now I go to the next set of grouping symbols, which are the brackets. And 13 plus 1 is 14. And 3 times 14, how do you do 3 times 14 in your head? Maggie. 3 times 10 plus 3 times 4. You're using the distributive property. Did you learn that last year to use the distributive property for problems like this? You break this 14 into 10 plus 4. You're doing this in your head. And then it's 3 times 10 and 3 times 4. And you add those together. Right? That's how you do single digit times 2-digit multiplications in your head, which all of you should be able to do. Right? So that's 42. 30 plus 12. Okay? You don't have a calculator for these order of operations problems because if you put this in your calculator exactly like this, with all the parentheses in there, it'll just give you the answer. So that doesn't help you learn the order of operations. Questions on this problem? This is the amount of work you should show for this one. All right, next one. 30 pencils divided among some students. Transfer this into an algebraic expression. What do I have to do first? Stephanie. Define a variable. If I'm writing an algebraic expression for a real world problem, I'm going to use a letter to represent some unknown quantity, or more than one letter. So what do you want to do for this problem? Define a variable. What is the unknown quantity in this problem? The number of students. So what letter would you like to use for that? S. Excellent choice. So I say S equals students. This is how I write my definition of a variable. I don't make you write a sentence. Let S represent the number of students. Okay, that's work that I don't need. S equals students. Number of students might be more useful. That's most important when you have something like items and cost. Like if you want to designate that the unknown is the cost of the item, or is the unknown the number of items, or there's two, then you might want to add that extra number in there. But S equals students is pretty clear what this is a count of, right? And what is the expression then, Stephanie?
30 divided by S.
30 divided by S. And what I'm not going to do is this. Okay, I'm not going to do this ever again because I'm in 7th grade and I'm getting ready for high school. And this is an elementary school division symbol, which I do not use anymore, except when I am dividing fractions. Come on, you eraser, knucklehead. How about undo? Okay. And we're not going to use that elementary school division symbol. So instead, I'm going to write this how, Stephanie?
30.
Over S. Okay, you could write a slash if you wanted to. But we write divisions as fractions from now on for the rest of your math career. Every division problem you write, unless it's dividing two fractions, which we'll do some later, every division problem you write is as a fraction, not with an elementary school division symbol. Good? Okay, number 9, GH over J. Number 9, GH over J. First step, substitute 6 times 10 over 5. You must show the substitution step. You must show the substitution step. Okay? Then 60 over 5, which is 12. Done. Okay? Last problem. 1 pint of liquid is 16 fluid ounces. Pint a pound the world around, 16 ounces in a pound. That's a number that lots of people don't know. Suppose the number of pints is represented by P, so they define the variable for you. You don't have to do it because they already told you what letter to use. Write an expression. Okay, so the expression is, Aubrey, 1 pint is 16 fluid ounces. Write an expression for the number of fluid ounces if you have P pints.
Divided by, 1 pint divided by P.
1 pint. Okay, so if I have 2 pints and each pint is 16 ounces, what am I going to do with those two numbers to get the number of ounces? Dividing the pints by the ounces is going to give me a little teeny weeny decimal number. Lucas, what do you say?
For the expression, you would write P, you would write P16.
P16. I would not write P16. It's correct, operations, but I would not write P16. Why not? Faith.
Because now it's number first.
The number always comes first before the letter, okay? So I don't need a multiplication symbol. I'm gonna multiply here, Aubrey, because if each pint is 16 ounces, then the number of pints times 16 is gonna give me the number of ounces, all right? 16p, okay? And then how many fluid ounces are in 5 pints? Well, then I just substitute in substitute in 5 for P, because P is the number of pints. And that equals 16 times 5, 80. Ah! Too close to the bottom here. 80, and if I leave my answer like this, I lose a point. Because the correct answer is, Maggie? 80 fluid ounces, okay, which you could put fluid ounces as FLOZ, okay? If I just put ounces, that's probably okay. The abbreviation for ounces is OZ. 80 ounces or 80 fluid ounces. And the reason they say fluid ounces is because ounces is also a measure of weight, right? Pounds and ounces is the same as weight, and pints and ounces is volume. So, okay? All right, that's it. Off you go. You're on your own for the rest of the class. I may adjust the assignment here. Hold on. What do we got? Oh my gosh, we got a half an hour left. I'm not adjusting anything. Go ahead.